I'd like to welcome you to my course, Exploring AWS IoT. I recorded the original introduction over a year ago, but now this is the updated introduction for the second quarter of 2019 to cover changes to AWS IoT related services on the cloud. I've also introduced new lectures and labs like AWS FreeRTOS and AWS IoT Analytics. So I wanted to keep you current to the cool changes on both this course and AWS IoT core services. So who am I? I'm Stephen Borsay, a degree computer engineer who specializes in device-to-cloud integration. My main areas of interest are helping software engineers connect their hardware to the cloud, assisting hardware engineers understanding IoT essential services in the cloud, and helping electronic hobbyists explore IoT for fun and profit. IoT is a hugely growing field and Amazon is committed to expanding its IoT services. So this will be a very useful course for those with a broad interest in IoT or a specific interest in AWS IoT. So now what is IoT? Well, everyone has their definition, and I'm not going to add a lot of value by reading something you can Google or easily look up on Wikipedia. But to me, IoT means inexpensive devices everywhere constantly sending data to the cloud, holding that data in some type of repository. For us, that means AWS services like DynamoDB or S3, and performing visualizations and analysis on that data as needed. We can do the visualizations with a variety of AWS cloud-held tools like QuickSight and AWS IoT Analytics, both of which we'll be covering in this course among other related AWS IoT services. So here's a basic diagram that somewhat illustrates how this course is going to be structured. On this side, we have our inexpensive IoT Wi-Fi equipped hardware, to which we will discuss more thoroughly in the coming sections in this introductory section, which runs specific AWS IoT compatible software onboarded and registered with AWS security credentials, running MQTT communication protocol, transmitting JSON sensor data packages over Wi-Fi. Now, if this was confusing, don't worry. I will be breaking down all these things in the first introductory section. Now, once we have dispatched our data to the cloud over here, AWS IoT Core, we can take advantage of AWS services on the AWS free tier, which is all about what's going to happen in the second half of this course. So I've kind of have a rough diagram of how the programming flow is going to work. This slide gives us more insight into that IoT flow. Here we have our ESP8266, but it could easily be the ESP32 or the Raspberry Pi. We'll cover it all in this course. Using specific free AWS IoT capable software to the AWS IoT gateway, triggering actions and finally dispatching our data to various AWS IoT services. Now this diagram covers hardware, software, TLS 1.2 security rules and actions, as well as these AWS services. Okay, let's take a moment to break down what we'll be covering in the subsequent lectures in this first introductory section. First of all, we just completed the first lecture. We introduced the topic and had this basic design flow that we're going to use throughout the course. Again, divided between mainly hardware solution over here and our software services over here. After this lecture, we're going to talk more specifically about hardware to connect AWS IoT Core. That means what devices we're going to be using, but here's already a preview. It's going to be the super cheap ESP8266, the more expensive but more powerful ESP32, or the much more powerful Raspberry Pi. But each device has its advantages and disadvantages, including price, size of the memory, and power consumed. After we finish the hardware section, of course, we're going to need to talk about the software section. Now, in this course, all the software we're going to be using is going to be free. So that's the good news. Mongoose OS, Xerith, Node-RED, it's all free. But there's certain capabilities where it has to be AWS IoT compliant and capable software. So you can't just use any software, but I'll be explaining the major free packages that we can use to connect these super cheap, inexpensive devices to the AWS IoT Core Cloud and that MQTT gateway broker. Now, after we discuss the software, we're going to have to spend a little bit more time talking about MQTT. Now, that MQTT communication protocol could be compared to other communication protocols, primarily the one we're most commonly used, especially for web developers, which is HTTP or HTTPS. MQTT is generally the preferred protocol for IoT because it's lightweight and you get both the publish subscribe from the device and the cloud. So it has some inherent built-in advantages. After we cover that, we're going to have to speak about services available for AWS IoT Core. That's these services over here. I want to briefly cover the ones we're going to be going through in the course, especially the ones that are super important like DynamoDB and S3. After we talk about AWS services, we're going to need to know how to set up the minor features, which includes, not so minor, setting up your AWS free tier account and the AWS CLI. That's a command line interface. Very important you know how to do that because both Mongoose OS and Zirnith, which we're going to use in this course, require the AWS CLI to be installed and configured. After we cover that, we're going to go on to AWS IAM permissions, policies, and rules. This is an area in the previous year I've had the most questions on. It's very confusing, and if you use other third-party web-enabled, IoT-enabled websites, you didn't have to worry about this, but AWS being a professional environment, they make sure every user has different policies and permissions for different services. So it's structured for a whole corporate type atmosphere, which of course we don't care about prototyping on our own, but we still have to know it because it's an integral part of all AWS services. So I'll make sure you understand that enough to get by in this course. Related to that, every device using that MQTT broker gateway needs AWS security credentials. We have 3 different security credentials we need to install on the device: the private key, the client certificate, and the X509 root certificate. Everybody gets confused about that. There's a couple different ways to do security certificates, and I'm going to show you both methods, but what's important is you'll easily know how, going through the course, how to install those credentials on your device using this free software. The good news is once you've created your first batch of security certificates, you're not going to need to do it again. You can keep reusing that same batch, and you can even transfer that exact same batch between all 3 devices. And you don't need all 3 devices. You can easily get by just the ESP8266 or no device if you're just going to sit there and use the testing tools like MQTT-FX and Node-RED. Okay, finally, we're going to talk about making connection to AWS IoT. Speaking of that MQTT-FX tool, this is just purely used to use the security certificates to test your connection and transmit fake data to AWS IoT. Once we know we can transmit data from our PC using Wi-Fi to AWS IoT, then we can go on to Node-RED and these other real software programs that actually install on the device and transmit on the device's Wi-Fi. But it's very good to use the simple MQTT-FX tool because it just verifies that you understand what's going on. It ensures that you know how to install your security certificate credentials correctly, and that you can actually make a connection and talk to the AWS cloud through the IoT gateway. So let's get started with the next lecture where we'll be speaking about this IoT-enabled hardware. And again, as a minimum, you should have this ESP8266 device for a few bucks, but if not, don't worry, we're going to get started with the testing tool, and you can always pick up the device later. But let's get into the specifics of these simple hardware devices. Okay guys, welcome back to the course, and in the second lecture of the first section of the course, we're going to talk about the hardware devices that we're going to utilize during this course, and which ones you may need or not need, depending on your preference, and which ones you might already have. So we have these 2 Espressif ESP devices. Here on the left is the ESP8266, and on the right here is the ESP32. So the basic difference is this ESP32 is a newer, stronger, more powerful version of the old one, but you can still do this course just using the ESP8266. We'll talk about it a little bit more in the software, but if you want to use Node-RED or Mongoose OS, you're fine just using the ESP8266. If you want to move on to using those 2 pieces as well as Zirnith and FreeRTOS, you can go ahead and upgrade to the ESP32. Cost-wise, this one you can get for about $4 or $5. This one's about $10 for the Dev Kit C. I will say that whichever one you buy on the ESP8266, you probably want one that's breadboardable. And what I've noticed is you want to get the 12E model because it has these pin rows out here. And also you want to make sure that it has 2 free rows on your breadboard. I know the very cheapest ESP8266s take up 7 out of the 8 rows of the breadboard. So just make sure if you're going to breadboard it, you get a free row on each side. The ESP32 Dev Kit C, it's the in-house made version using this chip. It's a little bit more expensive than a generic ESP32 board. The reason I'm recommending it is because it works with everything we're going to use in this course, including FreeRTOS. None of the other ESP32 variants will work with FreeRTOS except for the DevKit C. However, you can look at the Mongoose documentation, the Zenith documentation, and you can see if there's other generic cheaper versions, less than 10 bucks, which are out there, that you can use with. And then if you don't want to use AWS FreeRTOS, which is kind of more advanced production level software, then there's really no reason to buy the DevKit C. As long as in Mongoose or Zenith, you can use the version you want. All right, let's talk a little bit more about the specifications of each board. Now, for the ESP8266, it's based on the Tensilica single-core RISC MCU. It's a little complicated chain because what happened originally is Tensilica was its own company. It was bought by a huge company called Cadence. They make EDA software. And then it was licensed by a Chinese company called Espressif. And then later on, they ported it over to Arduino, which made it really popular. And it's got built-in Wi-Fi, which for $4 at the time, for the ESP1 version, there was no competition. However, recently in the last couple years, Espressif came out with the same licensing chain, but the ESP32. Basically, it's a more powerful chip, it's faster, a little bit more power hungry, but it includes BLE 4.2 and regular BLE, which makes it a pretty cool chip, and it's more capable. The number one thing that's going to make this chip for this course more capable is not the higher speed, it's because of the bigger memory for the user code and the TLS 1.2 library requirements. That's why this ESP32 can handle a lot more than the ESP8266. But again, for basic prototyping and just connecting using Node-RED or Mongoose OS, you're fine with just the ESP8266. It comes with 128 kilobytes of SRAM, whereas the ESP82 comes with 4 times more, which is 520 kilobytes of RAM. Now, as far as the speed goes, twice as fast here for the ESP32, 80 megahertz for the older board, for 160 megahertz for the newer board. That's the speed the MCU runs at, the central processor as far as embedded systems are concerned. GPOs, this has 17 GPOs. That's a little bit misleading because there's really very few that are usable GPOs for sensor devices, whereas there's plenty of GPOs available. Those are all the connections on these pins that are available to prototype various ancillary devices on your ESP board. Okay, now that you kind of know what those boards are about, let's talk about the Raspberry Pi, which we'll also be using in this course. Okay, so let's talk a little bit about the Raspberry Pi. So of all these specifications, the one to pay attention to is that it's the ARM A53 processor this board's based around. This means it's a lot closer to an actual PC or Mac than it is to an embedded system. This is an application level processor. So what that means to us is that this chip and these peripherals, they hold their own operating system. So unlike the previous truly embedded systems with those Espressif boards, we're not programming an operating system over bare metal here. This already has a Linux operating system and you can get it in different flavors running on the board. That makes our life much easier because we don't need a special software package like Mongoose OS or Zenith to put on top of the board. It's already running an operating system, so we're just going to put the code on the board, and it has a bunch of compilers that are preloaded with the Linux operating system. So to program this device, we simply need to use the AWS IoT SDK, and it has examples in multiple languages: Java, JavaScript, Python, I think now Rust and Go. So there's all kinds of options for programming this board to talk to AWS IoT Core. And this is why software engineers really love this board, is because they can get started really quick and they don't have to deal with programming bare metal and low-level C code. All kinds of options with the Raspberry Pi. So very cool board. Okay guys, sorry for the interruption in this course, but I want to talk about something very important to me. Maybe not as important to you, but I'll make it brief. 12 minutes into the course, Udemy has started to ask students to rate the course. In my opinion, it's much too early. We're not doing the fun stuff right now. We're covering all the necessary prerequisites. But nevertheless, here's my deal to you. If you don't want to give my course a rating, I would hope you would be enjoying this enough to give it a pretty high rating. But if you don't want to give it a good rating, Udemy offers a 30-day money-back guarantee. I'd much rather you get your money back if you're not happy with this course than give me a low rating. because high ratings are the lifeblood of the course. And for my professional career, I'd rather make less money and have higher ratings and make a ton of money off you guys and then not really have you get a lot of value with the course. So my suggestion is if you're not ready to rate the course now, which you probably aren't, wait. But if you do end up rating down the road, please, if you're not happy with the course, rather than leave a crummy rating, just get your money back. You can get a 100% refund, and I don't mind that at all. And I'm available here to ask any questions or answer any kind of questions or comments you have, so don't hesitate to either email me privately or post a message. Probably better to email me privately unless you have a message that you can post on the board that you think is helpful to everybody. All right, let's move on to the software section of the course at this point. All right, guys, welcome back to the course. Now, in this section, I want to talk a little bit about the software we're going to be using on those devices previously described in the last lecture. So the first piece of software we're going to use, and like all this software, it's completely free, is called MQTT-FX. We're going to use it simply as a testing tool. So how it works is it's based locally on your local machine, PC, Mac, or Linux machine, and it uses a MQTT-FX back Java-based program. It's actually the Eclipse Paho Java-based MQTT client. And after I show you guys how to download your security credentials from AWS, you're going to install them in MQTT-FX, and then we're just going to stick in a simple JSON test package, send it over via MQTT to AWS IoT Core under a topic name that we'll give it. This tool can hold our certificates for TLS 1.2. Now, after that, we're going to go through a full demonstration using our ESP8266 or ESP32. Both will work with Node-RED. Node-RED is also free software by IBM. There's two versions of Node-RED. There's a cloud-based static IP version and a locally based dynamic IP version. I'm recommending you use the cloud-based static IP because it's much easier to deal with because you don't have to constantly redirect your device via HTTP to a new address once it gets dynamically allocated by whoever you're paying for your ISP host. So that's why we want the cloud-based version, but I'll show you that when we set it up. But basically, either with your ESP8266 or your ESP32, you're going to program it in the Arduino environment. I'm going to give you those scripts for both devices. And I'll give you a script for pseudo data so you don't have to hook up a DHT11 environmental sensor. And I'll give you a script if you really want to hook up the environmental sensor. What I found from doing this course for over a year is people don't really care about hooking up the sensor. I mean, every other project on the internet shows you how to hook up. It's the most common sensor in the world. So it's up to you if you want to do that. But how it's going to work in Node-RED is we're going to configure an outbound node utilizing MQTT. An inbound node, we're going to use HTTPS, and actually HTTP. That's the most common protocol for IoT stuff. Normally use MQTT. I could use MQTT coming in on this node, but it's easier just not to, and it's compatible with more devices if I don't. Then I don't need a publish subscribe library on my ESP device. So this device, I'm going to give you a script. It's going to transmit a data package over to Node-RED. Node-RED's going to hold our security certificates in the cloud that we're going to upload to Node-RED. Then it's going to pass that data on as an intermediary over to AWS IoT Core. And what's cool about demonstrating Node-RED is there's a whole bunch of other features in nodes, and I'll show you some of those features later where you can generate pseudodata in JavaScript and do all kinds of stuff in Node-RED. So it's a really useful tool, and again, it's absolutely free. Okay, after that, we're going to use Mongoose OS. What's cool about Mongoose OS is it can hold TLS 1.2 security requirements on the device. It's the only standalone software program in the whole world that I think can do that. So it makes it a really good choice. And you can program it in kind of a subset of JavaScript or C. We're going to be doing it in JavaScript. It makes it a little bit easier, but it's just kind of a subset of the most basic functions in JavaScript just to send out this JSON package to AWS IoT Core. So we'll upload our JavaScript program into the device. It has a defined library for TLS 1.2 for security that'll hold our certificates. Then again, via MQTT protocol, it'll pass it over to AWS IoT Core. Now the next thing we're going to use as far as free software programs is Zirnith. These are all optional. If you've already done one or other of these, you don't need to do them all. But Xenith is cool because it uses a Python hybrid language. Now, fair warning with Xenith is that it can't do it on the ESP8266. It can only do it on the ESP32 because their TLS 1.2 library, when you consider Python code's much bigger than JavaScript or C, it can't contain all that in its memory space. So you have to have the more powerful ESP32, and it'll also transmit that data via MQTT to AWS IoT Core. And it has its own IDE and cool software. And it's really, if you like Python, this is a really great program. And the guys at Xenith contacted me and they're like, hey, we heard you're doing our course using our software. So they made this banner for me and they tweeted that out. And I thought that was really cool. These guys are based in Italy, really nice guys. Okay, after that, if you have a Raspberry Pi and you want to use the Raspberry Pi, just like I said in the previous lecture, we're going to use these AWS IoT SDKs. Now, I already told you they have these in these different languages. I think they actually may have more than this now, but Java, JavaScript, Python, C, and C++. You can use whichever ones you want. For this class, I'm going to give you as examples, simple examples based on what they have in the SDK in JavaScript and Python. This will get uploaded to your Raspberry Pi. You can use whatever editor you want to edit those programs and then run them. And of course, handling MQTT and TLS 1.2 security credentials on the Raspberry Pi is super easy because, again, this is an application level processor. Tons of memory, tons of speed, very powerful device. So we're not going to have any problem with this. Okay, the final one I'll speak about is Amazon FreeRTOS. Now, originally FreeRTOS was its own real-time operating system company. Amazon bought them. So what Amazon wanted to do is for professional development in low-level C, they wanted to have a common real-time standard so they knew that all their functions that you would program onto these different devices would get executed in time. So I will warn you that all this is in pretty low-level C, and the fact that Amazon is using FreeRTOS as a standard for certified companies that make products that can use FreeRTOS doesn't make things easier because it's still bare metal C. It's just wrapped in these real-time functions that help with semaphores and mutex and real-time requirements. So it's really a bonus lecture if you're interested in really seeing how true embedded systems work, but that underlying bare metal C is going to be different for every device used. Fortunately, the ESP32 is recently certified, so it's one of like 7 partners that's certified to use AWS FreeRTOS. So if you're interested in real embedded system programming for production level design, check out that lecture near the end of the course. Okay, let's move on to talking a little bit about the MQTT broker briefly, and then go through the rest of the introductory materials. Okay, welcome back to this part of the lecture. I just really want to talk about MQTT protocol. This is what we're going to primarily be using in this course, and because it's a lightweight protocol, for IoT specifically, MQTT tends to be very popular. So I want to just go over some basics so you understand it. First of all, MQTT stands for Message Queuing Telemetry Transport, and it's one of several different standards used for IoT. The other big ones are COAP and AMQP. I think that's mainly for government operations. But normally what you've seen if you've done any web development is HTTP, HTTPS. But MQTT is the big one for IoT because it has some inherent advantages. It's got the lightweight setup, but it's got this publish and subscribe based messaging protocol. That means when we're using MQTT protocol over TCP/IP, is we get subscribe and publish. So no matter where you are, just like a little node client here that's sending sensor data, maybe you only want to publish data from the device and then subscribe in the cloud. And then once it's in the cloud, you can do whatever you want. That process is exactly what we're going to do with AWS IoT. Now, if we want to use shadow service and actually want to, on AWS IoT, publish in the cloud and subscribe on the device, that will allow us to send data to the device. So we can publish and subscribe using that pub/sub models both directions with MQTT protocol. So again, a lightweight messaging protocol for small sensors, optimized for high latency or unreliable networks. The unreliable networks have to do with the QoS, which you're going to see really soon, quality of service. And it's just a guarantee as part of the MQTT protocol that you'll get the message once, you'll get it at least once, or you'll only get it once, depending on the QoS level. So that's pretty much it for MQTT. I just want you to know what I'm talking about because we're going to use devices on your local computer that work as MQTT brokers, But think about AWS IoT Gateway has a built-in MQTT broker, so you can publish and subscribe from the AWS cloud. Okay, let's move on to the next lecture.